those who couldn't come, but yeah. So the next thing is, how do you now get to repeat this so that you can, let's say, choose between moment and maximum likelihood? We need to be able to get a bias and mean square error. Okay. So how do we go about this? Well, I think the last time we wrote functions for bias and so and so. So what we need to computing bias and MSE. So we need to generate the data. It's two ways. You can do it several times and get it, or you can also generate the data. Once you have the data, then you can then find either the columns or the rows, right? So if I generate a sample, each sample is of size 10, and I repeat it 1,000 times, I can get a matrix or data frame of 1,000 rows and 10 columns, where each row is what? A data set. So what I'll do is that I find estimates for each row, and then I'll get a 2 by 1,000 matrix made up of maximum likelihood and moment. Each of them I find the bias, mean square error, and then I can compare them. Okay. So we'll go through the data generation approach before we. Okay. So data table, something like that. Okay. So how do I generate the data? Well, I can use supply, so which means I will need R as well. So R is equal to, let's say, for a start with state 5, which is the number of repetitions. The number of repetitions. Then S apply, right? I have 1 to R. Then I can generate the observations from a S gamma distribution, right? So it will be function. So you have to, if you go to the site, look for the apply family of functions. I've done a video on this, and then family of functions. Okay, so and then where's the S gamma? I can go up here and choose SG. I think that's the SG data, right? Yeah. So SG data. N is equal to N, theta is equal to N. What this does is that it's going to generate R repetitions of the same data of sample with the same sample size. So let me, okay, R is not found. So now I need to, so I'll start first with 10, which is quite easy. Okay, so if you want to do this, you need that as well. Okay, so now if you look at data, if I come in data, you see it's a list of 25. Okay, so I think I need to put SG here. Do you remember that our data comes as a data frame, but all we need is just that one here. So I should do it this way. That's why it was a list. So now you see it's now a matrix made up of what? 10 rows, 5 columns, which means each column is a data. It's a sample, so to speak. If I want it to be rows, I'll use T to turn the data around, which is transpose. Yeah, but it's okay like this. All we know is that each column is what? Each column is a data sample from S gamma distribution. Okay. Then what else? So it means that I can now compute the estimators, or estimates rather. Okay, so moment will be equal to, so each column apply, I'll take this data, each column apply 2 means for each column do, what was the moment est. So what this means is that take the moment estimate function, apply it to each column. Each column is a sample. So when I do it like this, I'm going to get 5 estimates of the theta. Theta is 2. So you see each of them is different. And I'll do same for the maximum likelihood. But that one, it needs par and x. So I cannot do it like I have done this. It won't know which is x, which is par. So I'll rather put a function there. So MLE, it will be a function. This one is a x, so it will take in the x, and then I think it's MLE. It's MLE. So x will be equal to this x, but par will be equal to, then I need to provide a par. So maybe I can just put 5 over there. All right. So if I do this, it also computes it. But when I come here, it's a list of 5. So it means the MLE, I need to also get the par, not all the list. We don't need all of them. What we need is just the parameter estimate. Okay, so like that. So MLE will now not be a list, but rather it will be you see it's also there, like a vector. So there is this, and the MLE is like this. Yeah, like that. So if I can go there and change it to 1,000, I'll get that 1,000, and then I apply my bias mean square error on each of them. Okay, so that's it. So how do we? I have to track back and get the way the mean square error function. Is like this. Bias one, and I think it's mean square. So it's theta. I need to run it. Where is the MSE? Where's the MSE? Yeah, there it is. So you have to run it. All of them, it takes theta hat and theta, right? Okay, so when I come here, I'll just, so I can bias.mom will be equal to bias fun, and then theta hat will be mom. Theta hat is equal to this mom, right? And then theta will be equal to the theta we started with, because each of these was an estimate of theta. Yeah, so we do this, and that gives us 0.37, and I can do so for what? For maximum likelihood as well. So this will be MLE. So here, instead of mom, it will be what? MLE. But the theta is the same. Okay, so I get this. That's also 0.41. So you see the method of moment is better. It has a smaller, yes, it has a smaller bias than the MSC. Okay. And we can do the same thing to get what? The MSCs. So I can copy the two and change these ones to what? MSCs. And then this one to MSC. So it means the other one also MSC. It's MSC fan. MSC fan. Yeah, that's it. Okay, so let's see. The MSC is 0.49, 0.5. So mom is better. But these are very small. When you finish, you can. And when you are done with this, you can now put all this together in a data frame. So if you like, you can get, do you want the biases to be together? The bias will be assigned C and then you can also do the MSC MSC like that. Okay, so now if you, but I need to do the row names of it so that I show that this is for moment, this is ML. Is that okay? So row name. So whatever I've done now, when you go home, you can also put it in a function so that it generate. All you want to see is the bias and MSC so that you make a decision. Yeah. So we can put all this in a function so that when you give it to a computer, it will generate. You get a sample size, you get these ones, you get all your parameters, and then it gives you bias and MSC. Bias and MSC, bias and MSC, then you use that to make a decision. That's how these things are done. So row names will be C. The first one is moment, and then the other one is what? MLE. Okay. So now if so you see moment and MLE and so forth. But essentially, when you are done, you want to put all these together. So it means that you need a function that will take n, theta, go in, and maybe the power, the starting value. It takes n, it takes theta, it generates all the data, calculate the estimate, compute the MSC and bias. If you like, you can even add the median or the mean of the estimates, and then it brings you that. That's how we make decisions. And so if you go to the paper and then you check, you realize that they will be giving you a table. That's the sort of thing they were doing. That when theta is equal to this, n is 20, this is the bias, this is the MSC. Yeah, so you can collate all this and then put it together. So once you look at it, you see as n increases, what happens to your bias, what happens to your MSC. If it has to show empirical consistency, then you expect the mean square error to decrease as n increases. So if you look at this one, you have 0.0020, then you go to 0.009. So you see it's actually decreasing. So it's actually showing empirical consistency. Yeah. So that's the sort of thing we have to do. Yes. Yes.
You need to simulate their data. That's what they've done.
No, if I'm doing, if I suspect, because people can also do fictitious stuff. So if I suspect that the result they have given So I can replicate it on my own. If I don't, I can tell the editor to request the authors to provide the code.
Okay,
Yeah, you can request, and then they will send. So once they send in, then you do it. But this is a straightforward thing. If you request, then they know that you don't know what you're about. So that's why you can easily write, and then if I do it and I realize that they are, then I'll report back that what they have done is actually not correct. So if you don't have any suspicion, but when you are reviewing, you will know that, well, even what they have done, if they're able to derive the maximum likelihood, remember that's why in your statistical inference you study properties about the maximum likelihood estimator. So that theoretical stuff must be demonstrated in this. Yeah, so that's exactly what you hope to see. Yeah, that's it. No, this one is not yet used. Okay, so that's it with this section. So the next thing you have to do is to put all this into a function, such that if you want to check the bias and the MSC for theta is 0.5, n is 10. Then when you finish, you get n is 50, n is, then you don't need to be interacting with the computer all the time. So put all this in a function. It means that from here, you see, I need R, which is repetitions. I need N, which is the sample size, and I need theta. That's the three things. So the function should take R, it should take N and theta, which you provide, right? And then all what it has to do is to generate the data and compute this and compute that. So your table of values, you can get the mean of the theta, which should approach the theta that you started with. And then you have the bias, you have the MS as the output. So try that and let's see. So if you do that, you see that whatever you get should mimic what they have provided in that table. I think they even use just one. I think the MLE, they did not include the moment in the table. But we can go a step further and do that. And then you can check if you can get the data. But if you get any data set, you should now be able to apply this onto it and check what it is. Okay, so that's it for tonight. I'll send you the code on your platform. And then you can.
Are in action.